let's see. Okay. Okay. In the sciences, particularly the physical sciences, that would be physics, chemistry, geology, molecular biology, engineering, we measure stuff. Next week, you're going to be doing your first lab. You're doing a lot of measuring next week. The problem with whenever you measure anything is you have an inherent error built into it, either because of your eyes or the instrument's wear in precision. So whenever we talk about numbers measured, I want to emphasize measured. Very important that they're measured. There's something called significant figures that goes along with it. And those significant figures are a way of measuring how precise that measurement was. So from now till the end of the semester, we're always going to be considering numbers with significant figures in it. And that's what today's dry lab is all about, and tomorrow's dry lab, on significant figures. Every single problem you do in here that involves numbers, we're going to be worrying about significant figures. So that's what I want to talk about today. So significant figures is a method to determine remember now, I'm recording all this. It's good to take notes, but I am recording all this. Okay, it's a method to determine the precision of the measurement. So, and there are rules associated with it. So what we're going to do is we are going to so I'm going to give you some numbers now, and we're going to develop some rules. And I abbreviate significant figures as SF. So from now on, SF is, I call them, a lot of people call them sig figs. No one ever pronounces significant or writes it out. It's just a pain. But anyway, okay. So number of sig figs in the number. Okay. So let's look at this number here. How many sig figs do you think that number is? The wild guess. 3. You're right. Tough, huh? What about that? 3. And that's also correct. How about that? 1 and 3. And 1 is correct. Okay. How many sig figs do you think that number has? 1 and 3. What's the difference between those two numbers? 100's 100, right? Decimal point, exactly. Decimal point is a big deal with zeros. So keep that in mind. That's scientific notation. We're going to talk about that as well in this class in depth. We have 2. 2's right. Okay. What about that? And the correct answer is 2. Again, we've got zeros and a decimal point. That's where things get dicey. Let's see if I covered all the examples. What about that one? Any other? Okay. 3 is correct. Okay. So what's the deal with zeros and how do those come into play when you're talking about significant figures? I'm going to call these zero rules. And there are 3 places the zero can be: the beginning, middle, and end. So when they're at the beginning, they never count. So looking at this here, those zeros don't count. So what's left? 31, that means 2 sig figs. Middle. Is there a machine in here making a lot of noise? I know. Oh, is it Ben up there? God, it's noisy. You know, they broke ground for the new science building. Okay, when zero's in the middle, it always counts. Now, the tricky part is when it's at the end. Now, there are 2 situations if zeros are at the end. Okay, if there's a decimal point present, they count. And if there's no decimal point, it doesn't count. Okay. So 0 in the beginning, never count. Zeros to the end, count if there's a decimal place. Anywhere, doesn't matter where the decimal place is. If it's in the number, beginning or end or whatever, those trailing zeros will count. And always in the middle, like 101 is that 0 always counts. Okay, does everyone understand those rules? And you're going to be using these for the rest of the semester. Yeah. That 101. In other words, it's not at the beginning, not at the end. It's
but it only counts if there's numerical greater on the
yeah, it's got to be something other than 0 on the end.
Yeah.
Yeah. That's what you're saying, right?
right, of
Yeah,
course,
yeah. Yeah, exactly. Yeah. If it's at the end and there's a decimal point present, it counts. Okay. Huh? Yeah. So if you have that number, okay, trailing zeros, right? How many we got here? We have 4. Okay. There's a decimal point there. So all 4 of those zeros count. So this would have 6. Yeah. In the beginning, never. That's right. Now you're going to practice this a lot today and tomorrow in lab. The whole focus of lab is significant figures. So you'll have lots of opportunity to practice this. Okay, so all right, any other questions about the rules? Remember, I'm recording this too, so. All right, so we have two computational situations in physical science classes. Add and subtract, multiply, divide. And they're subsets of all those, but basically that's it. Excuse me. Now, so adding and subtraction, what we're doing is we're looking at the decimal places. So we're not looking at the total sig figs in those numbers. We're just looking at the decimal places only. So how many decimal places is the top number? 1. How about the second one? 2. So our answer is going to have 1 place, decimal place. Now we're always going to go to the least amount, the least number of sig figs. Always. Now you can think of this. Let me give you an example. If we have a chain and the chain has got links in it, right? The strength of that chain is the strength of the weakest link. So say we have a box of links and we're going to make a chain and they're all will hold 10 pounds, except for one of them. One of them will hold 1 pound. So we put all the links together in the chain. How much can I lift with that chain? 1 pound, because if I go to 2 pounds, the 1 pound link will break. Doesn't matter. The other links could be 100 pounds. Doesn't matter. The weakest one is 1 pound, so it can't lift anything more than 1 pound. Same with significant figures. We're always looking for the least significant answer. Numbers in there, significant figures. Okay, so let's add this. This is a really hard problem, okay? So the answer is 3.4, not 3.40 like you'd get on your calculator. All right, so now this is only for addition and subtraction, not multiplying, dividing. There's another set of rules for that. Okay. Okay, so we've got 1 there, 3 there. So our answer is going to have 1 decimal place. So if we add this on your calculator, we're going to get so is that the answer? No. Got too many decimal places. So we have to now round. So whenever you round, you go to the next one over. So we need to go 1 more than 1, which is 2. So we go to the second place. And that's 5. 5 or more, we round up. So the answer to this problem is 4.9. Now, the only thing that's kind of weird is when we're dealing with money, money's always 2 decimal places. You always move everything around so it's 2 decimal places. Money's a weird one. Okay, so does everyone understand where I got the 4.9?
Decimal places thing, so I get 1 decimal place, and under that it's 3, but how is that, so that the one you get that, because it's use the one with the least amount of decimal.
Exactly.
How do I apply that to?
Yeah, so we need to round the answer to only have 1 decimal place.
Oh, okay. gotcha, okay.
So that's why we go to the second place. Doesn't matter. We can have 29 more nines. The only one that counts is the one right after the one. Better?
Yeah.
Huh? No. It depends on the problem. In this case, we run to one, the one's decimal over the tenths place because the smallest one up there is 1. Is 1.1, 1 decimal place. 3.756, 3 decimal places. Okay, 1 smaller than 3. So that means our answer is going to have 1 decimal place in it. Our answer's got 3, right? So we got to fix it. So we go to the second place and then look at that number. If it's 5 or more, we round up. If it's 4 or less, we drop it. Yes, when we're adding and subtracting. Write down in big letters. Adding and subtracting. If you have a red pen, write it in red. Only adding and subtracting now. Okay, we all okay with that? All right, so what happens now? If we're multiplying, dividing, or doing exponential notation. Okay, then we're looking at the total sig figs and the numbers. So let's multiply that. By the way, who has not purchased a calculator yet? Anyone? Okay. If you're purchasing one, look, one, I would recommend a Texas Instrument one as opposed to a Casio. And second, Casios are fine. They just do everything differently. And it's everything, every example you get is always, the instructions are always TI or Texas Instrument. Make sure it's got an EE key on it. EE, yeah. Okay, so 365. Okay, so that's what my calculator gives me. Now, when you multiply and divide, you look at the total number of sig figs, not decimal places now, total number. So we've got 3 sig figs there, 2 sig figs there. So our answer is going to have 2 sig figs. My calculator gave me 3 sig figs, so I've got to fix it. So you go to the next place over, which is here. That number is 0 to 4, so we just drop it. So the answer is 5.1. Now, whenever I give an answer, I always write the number of sig figs, and that's just for your clarification. You can do that if you want, or you don't have to. If you're OCD, you might want to do it. I've had a number of OCD students, and I'm not at all. In fact, my second wife was OCD, and that's why she's my second wife. So, all right, so the answer is 5.1. Frequently, I'll circle it. You can do a box. Just if you have multiple numbers on the page, is on a test, you need to make sure I understand what your answer is. I don't want to guess. Okay, so you look at the total sig figs. Doesn't matter if you're dividing, multiplying, and then your answer is going to be the lesser of the 2 or 3 or 5. Doesn't matter how many numbers we're talking about here. Because later, tomorrow, for example, we're going to be getting into word problems. And sometimes we may have 5 or 6 conversion factors, and they all have their associated significant figures for each one of them. Okay, so does this make sense? Okay. Now a fraction is a division problem. A fraction is a division problem. That is 5.65 divided by 3. That's what that indicates, that fraction bar. So it's a division problem. So it's going to come under the same rules as multiplication, division. Okay, so 565. Yes. Calculator gave me 16.95. All right, how many sig figs is 565? Oh, right. You know, right. No, I totally agree with you. Oh, I hit the multiply sign. I multiplied 3 times 5. That's, you got to hit the right key on your calculator. A whole bunch of 8s. Okay, so how many sig figs should our answer have? How many? 1. Because the 3 has got 1 sig fig, and the top number has 3 sig figs. So our answer is going to have 1 sig fig. So we go to the second sig fig, which is the 8. 5 or more is going to increase the 1 to 2. So our answer is 2.
Oh, sorry.
Always go to the next one. Yeah, always. Exactly. Huh? Yeah, multiplication division.
For decimal speed, that's so this addition and subtraction delay, and if there's 2 decimals delay.
Yeah, addition and subtraction just looks at decimal places. It doesn't look like the sig figs of the total number, just decimal places. But when you multiply and divide, which 99% of the stuff we're doing in here is multiplying and division, by the way. We're not going to be doing a whole lot of adding. The only time we're going to be adding is we're going to have to do with the periodic table. And the periodic table is already rounded to 2 decimal places. So when you add numbers in the periodic table, it's already rounded to 2 decimal places. So you're really not going to do much of anything with adding subtraction. Now your dry lab is going to mention it just because you just need to know about it. But in practice, we're not going to be using too much adding and subtracting. Okay, is everyone okay with the 2 as the answer? That clock is incredibly wrong. God. All right, so let's do a couple more here. Okay, 1.2 times 10 to the 5th divided by 0.34. Now, on your calculator, did everyone bring their calculator curiously? Okay, I have some loaners in the lab, but you should start bringing your calculator, particularly for unit 1. Unit 1, 4, and 5 are very mathy. Okay, so on my calculator, if you have a TI with EE on it, this is the way you do this problem. You go 1.2, hit the EE key, 5, hit the divide key, enter. That's if you have a calculator that's got an EE on it. Now, sometimes you have to shift to get to your EE, sometimes you don't. Now, if you can do this problem without a calculator with an EE, this is the way you'd have to do it. So the EE saves you strokes. So if you have an EE on your calculator and you don't want to use it, you're gonna have to do, it'll take a few more steps to do. You'll get the same answer. Okay, and let's see what this is. So that's the answer my calculator gave me. So let's analyze this for significant figures. How many sig figs is up here on the top one? 1.2 times 10 to the fifth. How many sig figs is that? It's 2. The reason why it's 2 is because you only look at this part of a scientific notation number. Okay, so this has got 2 sig figs, 2 sig figs. So our answer is going to have 2 sig figs. So we go to the third place. That's 0 to 4, so we drop it. So it's 3.5 times 10 to the fifth. Okay. All right. So you're going to be practicing a lot today in lab and tomorrow, depending on what lab you have. All right. I want to talk more about scientific notation. Okay, purpose of scientific notation is to make awkward numbers less awkward. Now, awkward depends on who's teaching the class. Something could be awkward for me, may not be awkward for you. And it depends on your next class, what the teacher will define that as. But basically, if we have a number, and we're going to be, when we get into unit 4, we're going to have some really giant numbers. numbers like with 23 zeros in it, called Avogadro's number, huge, huge, huge numbers. So everything, unless we use scientific notation, is going to be very awkward. So we want to use scientific notation whenever we can, if it's an awkward number. So let me give you some examples of awkward numbers. That's an awkward number. So to make it less awkward, even though you may still think the answer is awkward, is going to be 4.6 times 10 to the minus 10. Okay, so there's a few things about scientific notation let's talk about. That number there is a number from 1 to 9.9999. This is an integer, always an integer. The exponent is always an integer, and it's either positive or negative. If the number is less than 1, the exponent is going to be negative. If it's greater than 1, it's going to be positive. So, yeah. Right. Yes, I'm going to talk about that in a second. Well, you're right. And what is 10 to the 0? 1. That's right. Any number to 0 power is 1. Okay, so keep that thought now. Good question. Okay, all right. So let's convert that to scientific notation. Okay, excuse me. Number 1, it is less than 1, right? So that means we're going to have a negative exponent. So we need to get the 0.00046 to 4.6. And what do we do to convert that number to 4.6? Are we going to divide or multiply? No. It's got to be the other. We have to multiply because this is tiny number. This is a much bigger number. So to go from the tiny number to the big number, we have to multiply. And what do we multiply by? Well, there are 9 zeros plus an extra one. So if we go like this, that's 10 places. We had to move it. And because it's less than 1, it's going to be a negative exponent. So just look at the number. It's a really small number, negative exponent. And then you're going to count over till you get to a number that's between 1 and 9.9. And however many of those you count over is your exponent. So I counted over 9 zeros plus an extra one to get us a decimal point between the 4 and the 6. That's 10 places I went over. Hence, that's where the 10 comes from. Okay. Now, another way to look at it is I multiplied that tiny number to get to 4.6. So if I multiplied to get to here, I have to divide to compensate for that big time multiplication. And that's what the 10 to the minus 10 is. Because the value of the number can't change. We're just kind of renaming it, making it less awkward. But the value of the number is the same. Okay, so let's look at Everyone okay with that? Now, a trick question frequently on tests, sometimes on my tests, I'll say, convert these numbers to scientific notation. And one of the numbers is like 5. How will we convert that to scientific notation? First of all, it's not scientific notation because there's no exponent in there. This is where your question comes up. There's no exponent in there, but we have to have one in there to be scientific notation. So what are we going to multiply 5 by? It's 5. One. And any number to the 0 power is 1. So 10 to the 0 is 1. 1 times 5 is 5. So that's where it comes in. Yeah. 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 But it made a simple number awkward. The purpose of scientific notation is to make it not awkward. But they'll always, this question comes up a lot. So keep that in mind, you guys. If you're trying to calculate scientific notation number that's small like that, you're probably going to be using 10 to the 0. Or if your exponents cancel out, you end up with 10 to the 0, it's 1. Yeah. No. 0. That was my cursor you were looking at. Okay. So it is 12:06. Let's do another problem or two, and that'll be it for today. Okay, here we have 2 scientific notation numbers in a division problem. So again, your EE key, for those of you who have, and the scientific calculators on your phone aren't as good as a standalone one. They work okay, but they're not implemented very well. Now, if you have internet available, you can get a TI-84 simulator on internet. It works just exactly like this calculator. That works much better than using the built-in calculator. Also on your built-in calculator, if you're in portrait mode, it's one kind of calculator. If you're in landscape mode, it's another kind of calculator. Usually landscape is scientific, portrait is simple. Okay, so let's do this now. Now, because I have an EE key in this, it's going to make it much easier. The big mistake on doing this problem, if you don't use the EE key, is what do you do with that bottom number? Okay, so I'm going to show you 2 ways to work this problem. One correct, one incorrect. Now, depending on how you work this problem, you're either going to get the top one or the bottom one. The top one is the correct one. Now, the reason why the bottom one is not the correct one is because when I entered the bottom number, I put in 4.6 times sign 10 to the minus 4. Isn't that what that says there? 4.6 times 10 to the minus 4. Now your calculator is dumb. It does not know it's in the denominator. It thinks it's in the numerator because I didn't tell it it's in the denominator. So if I would have put this in parentheses, it now knows it's in the denominator. If I put it in parentheses, I'll get the top number. If I don't put it in parentheses, I'll get the bottom number. That's where the EE key comes in, because the EE key basically glues these together without the use of parentheses. That's where it saves you keystrokes. Saves you 3 keystrokes each time you use EE. Okay. Let's see. I'm going to do one more thing. Now, tomorrow I'm going to be getting into problem solving. And well, that's what I'm just cover that tomorrow. What I wanted to show you an example is if you have a bunch of division problems in a row, there's 2 ways to do it. Yeah. As opposed to 0 point with 6 zeros, 2, 6. You mean significant figures? Let me finish this problem because we need to do 3 sig figs on this. So we go to the 4th one, that makes that 26.7. Okay, so some teachers make you write everything in scientific notation. And I don't believe in that. Because if a number, is that awkward number to you, 26.7? No, so why convert it? It's your decision, it's very subjective. Now, if you wrote it 2.67 times 10 to the 1 on a test, I would not mark it wrong at all. Because it's the same thing. It's just that I want to, this question had to do with, should we always convert to scientific notation? No. If you feel the number's awkward, do it. If you're comfortable with the number the way it is, leave it. For the purpose of scientific notation, under my purview, is to make awkward stuff less awkward. And if you find that simple and not a problem at all, leave it. Because we have enough stuff. Enough stuff to deal with without having to worry about converting everything to scientific notation. All right, yeah. I have a question over here. Okay, all right. All right, so your lab today, there's a problem with labs on the first day. Is who has Monday, Wednesday lab? Okay. Who in that group has not purchased your lab packet from the student store? Okay. Usually fair number. So what I've done is I've put a digital copy on Canvas for you. So let me show you where that's located. Are there questions about this scientific notation bit? You'll be going back and forth on this in the dry lab as well. Okay. Okay, so I'm back on Canvas here. I'm going to go to Canvas Files, Lab Related, and see it says Lab 1. So that is dry lab number 1. So if you haven't purchased your packet, you can do it this way. Oh, while I'm on this here, I want to talk about something here. in my class and your subsequent chemistry classes, 1A, 2A, 3A, most of the time, in my class, it's 100% of the time, but sometimes in other classes, they'll want you to say ambiguous here. So for example, here, that has 2 sig figs because the trailing zero has no decimal point. Well, in the math department, they go, well, that's ambiguous. You can't tell how many significant figures it is because there's no decimal point. Well, so you treat it like it has 2. You treat it as the least significant. Now, it's up to you whether you want to write the word ambiguous or not, but it's kind of useless as far as I'm concerned. That's why they have ambiguous on there, just to cover all their bases. And if I was doing this worksheet, I would not have put it in, but guess who didn't do the worksheet? Okay, so anyway, what I'm saying here is that your dry lab 1 and 2 are online for you, for those who haven't got the lab packet. But you need to get your lab packet because it's going to require a lot of write-up for the wet labs, which is going to be next week. So it's important to have the lab packet because that's where you're going to get your lab write-up stuff from. It's things like procedure, background, purpose, calculate, all that stuff is in your lab packet. Okay. All right. So those of you who have Monday, Wednesday lab, I'll see you at 12:30 because I have to pack up all this stuff. Yeah. You know your CRN number for the class? One it begins in 98, the other's 99. You log into Canvas, it'll tell you. And if it's 99, you're on Tuesday, Thursday. If it's 98, you're Monday, Wednesday. Are you into Canvas yet? Huh? Right. Is this class listed on there? 9/8. Okay, so you have Tuesday, Thursday left. Huh? Okay. Yeah. No, absolutely not. Yeah. No, no one's older than me. I'm 74. Are you older than 74? Well, see, I understand our challenges. So it's not a problem. Just it won't be rude to me. I totally understand. Absolutely. You're doing fine. Oh, yeah.
Is it 12:30 or 12:45? You said 12:30, like.
Yeah. Frequently our lectures don't go all the way to 12:30, so we'll start a little earlier.
Okay.
But yes, officially it's 12:45.
All right.
But would you rather stay later and kill a half an hour out there? Yeah. Every day this week, we're gonna have a lecture from 11 to 12:30. Every week, all 8 weeks. And then you're gonna have 2 labs once a week. Okay. All right.
Can I ask some like general stuff?
Yeah.
Like,
Yeah.
wait.
Ask me while I'm putting stuff away. I gotta.
Where's the bookstore?
Have you been to the bookstore yet? Oh.
Okay.
Oh, yeah. Follow her.
Okay.
I've never been to the bookstore. I call them on the phone all the time, but I've never physically been there. Jay, it's
I can buy like.
everything. Yeah. Check out the lab free ones though. Right outside the door. Yeah. They're on a rack.
Okay.
So go through those before you buy one.
Okay.
Because they're the right price.
But like I have to buy, they don't have to buy the package, right?
You have to buy the lab packet for
Yeah,
sure.
yeah.
For sure. And you need goggles too.
Okay,
But the lab coat though, might as well get a free one. So
okay. The 3 ones for lab coat, like I have to buy the goggles in the packet.
Yeah.
Okay.
that's fine. Mhm,
I
yeah.
like. And then this calculator, so you said in the,
Yeah, see, it's got EE on it. It's
Yeah.
perfect. Perfect.
you said that something cannot be used on tests. You said like iPhone or anything with graphing. would
No,
just so,
graphing's
like,
fine. The reason why people see this is a graphing calculator. And the problem is with graphing calculators, you can store information in it. That's why a lot of teachers, but if a student has this in my class, I just have them clear the memory. It takes like 3 seconds.
Well, I have that, but I also have this. So this can be used on tests, right?
Yeah, I would recommend using that one because see, to get to EE, you've got to do a shift,
Right.
where that one you don't have to.
Okay. And then, when you're, so this is the way where all these formulas we're testing the strength, right? We're testing the strength of the answer.
Yeah, it's not the strength of, think of it as just sig figs or the
Okay.
precision of the answer,
I
not the
was trying
strength.
to draw a correlation stats like the p-value and the coefficient R, but no. it's a completely
No. That's also a measure of,
different Strength, yeah,
well, it's,
accuracy,
yeah, it's how how close the dots are to the line.
yeah,
yeah.
but this is.
It's sort of in the same ballpark, but it's
Okay.
very different. But the concept is the same though. You know, it's how precise is your answer. You know, how do your answers correlate to the real one?
Right. It's like
That's what the R value is.
same idea, but
Yeah, exactly.
yeah. I have some questions. So would it be best to email you these? Or,
You have Monday Lab?
well, actually, yeah, so I signed up for Monday, Wednesday, but I'm gonna do Tuesday, Thursday.
Okay, that's fine. Why don't you, I gotta clear all this out and I gotta take this back. Just follow me around.
Oh, but I didn't wanna, cause there's a line. So I didn't
Yeah.
wanna, like, okay, I'll let you guys go first.
Okay, so who's next?